Okay, so this was just a video somebody requested about today's work, this week's work. Okay, so this week we're looking at solving polynomial equations, and we'll be using similar techniques that we've learned from solving quadratic equations, which is right over here. We need to make sure the equation is equal to 0, which for this example it already is. And then we have to find the greatest common factor and factor it out. And then 3, set the factored equation equal to 0. Okay, so what do I mean by all this? I'm just going to show you this right now. So here, like I said before, this whole equation needs to be set equal to 0. Once it's like that, we can move on. And here, so this step is already done. We can move on to find the greatest common factor. Now, greatest common factor, you can break it up into two parts. You can find the greatest common factor of the coefficient, and then I'll show you how to find the greatest common factor of the variables. But first, let's look at the coefficients. We have a 2, we have a negative 12, and we have a positive 18. So if you're trying to find the greatest common factor of these coefficients, you need to ask yourself, what multiplication table, so like your 2 times tables, 3 times tables, all those tables that you've learned in middle school and elementary school, has a 2, a negative 2, a negative 12, and a positive 18. So if we think back, I know that all these numbers, they pop. I know there's an 18 in the 6 times table. Oh, there's an 18 in the 6 times tables. 12 and 18 show up in the 3 times tables. And they also show up at the 2 times tables and the 1 times tables. Now let's go through all these factors. So 16, it has an 18 and 12, but it doesn't have a 2 in the 6. In the 6 times tables, I meant to say, it has an 18, it has a negative 12, but it doesn't have a 2, so I'm going to cross that off. In the 3 times tables, again, it has the 18 and the negative 12, but it doesn't have that 2 over there, so we're going to cross that off. So it's between 1 and 2. All right, and now we want to find the greatest one. So which factor is the greatest? So this one, between 1 and 2, it's going to be 2. So that's the factor we're going to take away. We're going to factor out from the coefficients. Now let's turn our attention to the variables. So we have x cubed, x squared, and an x. So from here, when we're trying to factor out the variables, right, we need to ask ourselves which exponent can be the most taken away. Okay, so what I mean by this is I know I had the exponent 3, 2, and if I don't see anything, 1. So which of these exponents can I take away from all of it? So let's start with 3, right? I can take away 3 goes into 3, but you can't take away 3 from 2 and a 1. You'll just get negative exponents, which we know we can't have. So that's off the table. What about 2? Well, 2 you can take away from 3 and 2, but 1, that's going to be an issue. Now 1, yeah, you can take away from 3 and 2 and itself. So that one is going to be our perfect choice. So the greatest common factor that we are going to factor away from this equation is going to be 2x. Right? Another way of seeing the exponents is like what exponent goes into all 3 of these variables. Okay, so we're going to factor out the 2x, and when we mean by factor out, we mean divide each of the parts. So if we have 2x to the third, if we divide 2x from that, the 2's cancel out, And remember, when we're dividing exponents, we're actually subtracting them. So you're going to get x squared. Okay. Now let's look at this one, negative 12x squared. If I divide 2x from it, remember with the exponents, you're actually subtracting them. So 2 minus 1, that just gives you 1. And then negative 12 divided by 2, that gives you a negative 6x. And then you're doing 18x divided by 2x. The x's are the same, they cross off, and you're just left with 18 divided by 2, which is 9. And that's all set equal to 0. Okay, so we found the greatest common factor over here, but now we have this x squared minus 6x plus 9. Now when we're trying to factor things, we want everything to be broken down to the smallest possible number. Like we don't want this x squared. So we want it to have we want the x to have the exponent of 1. So from here, we need to ask ourselves, what two numbers multiply to give you 9, but add to give you negative 6? Okay, so from here, well, if I do a negative 3 times a negative 3, I get a positive 9. But if I do a negative 3 plus a negative 3, well, that gives me negative 6, so that works. So the answer over here should be 2x x minus 3, because I want to put this as an expression, and this other one is x minus 3 over here. And then you're going to set all of so now you have it all factored out, and just like the last step, you're going to set everything equal to 0. So this will be set to 0, this will be set to 0, and this also will be set to 0. So a really neat trick that some of you made up when we were doing this with quadratic equations was just find the opposite of this. So what's the opposite of negative 3? Positive 3. The same thing over here. And now here, this is interesting. You have 2 times x is equal to 0. So what's a number that whenever we multiply it to a different number, it just gives us x? Oh, sorry, it just gives us 0. Well, anything multiplied by 0 gives you 0, so x equals 0. So the solution over here would be 0 and 3. And then we are done. Okay. Let's look at a question from similar to, let's look over here, this type of question. Sometimes they're going to ask us to find the zeros. So here, what they mean by find the zeros, they're asking us to find the solutions. And what we need, the extra step we need to do over here is to set everything equal to 0. So this h of x I'm replacing as 0, and I'm just bringing down everything else. Now in this equation, if you notice, we have a coefficients of -1, -1, 9, and 9. So there really isn't a greatest common factor, it's just 1. But if we factor out a 1, it's going to give you the same problem. It's not going to change. So a different way of factoring is you can actually section off everything. So I'm going to look at this problem, and I'm going to look at what are the numbers that go together. 9 and 9 go together because they're in the same multiplication table. And -1, -1, the coefficients go together. So I'm going to break it off like that. Negative x. Oops, I meant plus 9x plus 9. So I just broke it up. I just rewrote the same thing. I just add the brackets. And now within the brackets, I'm going to factor them. So let's start off with the x's. So what's a the greatest common factor of these guys? What's the exponent that I can take away from both of them? So if you notice that I can actually take away 2 from both of them. So what I'm going to do is I'm going to draw my bracket, and I'm going to take away a -2 squared. Actually, no, I'm not going to take away, no, yeah, I'm going to take away -2 squared. And I'm going to be left with, let's see. So if I do negative x cubed divided by negative x squared, I'm going to get x to the first. And then over here, I have a negative x squared divided by negative x squared. That just gives me a 1, a positive 1. Okay, so I'm set with that bracket. That's been factored out. And now let's look at this other bracket. They both have 9s. So that's something I can take away from it or factor out. And again, I'm just going to be doing the same thing. I'm going to be dividing 9 from each part of this problem. So I'm going to be doing 9x divided by 9, which is just cross that off. You just get an x. And then you're doing 9 divided by 9. This 9 divided by that 9 and equals 1. So this is a positive 1. Now you're probably just wondering, okay, so I'm done now, right? Well, the thing is, the difference between this problem and the problem above is that, well, this one we could have just left it alone because there wasn't any constant to be with it. In this problem, you have the mini expressions, but you still have negative x squared with that positive 9. We have to get rid of that. So I'm going to rearrange this problem again. I'm going to I'm going to keep the brackets. Negative x squared plus 9. And then this one is going to be, oops. And this one is, oh, and you're not going to write the plus sign. You're just going to have 2 different brackets. X plus 1, x plus 1. Okay, so now I need to factor this. Now, with this sort of equation, it's tricky to factor it because you have that -1. But we've seen patterns before where if it had this sort of pattern, it's easier for us to factor this. So to make this look like that, we need to do some algebra. So let me see. Let's move this up here for a bit. And let me just erase that arrow. So what I'm going to do to both sides is I'm going to divide both sides by -1. I just want that x squared to be positive because having a leading coefficient that's positive, it's easier for me to factor. So I'm going to wind up with x squared minus 9. Okay, so I just changed that. I want that first coefficient to be positive. Okay, and then from here, you're going to find those 2 numbers that multiply to give you the constant, which is -9. No, which is -9. Let me write it over here. Oops. And then we're finding 2 numbers. When we add it, it gives, well, you notice how there isn't an x variable. We just have an x squared, and we just jump towards -9. That means there's no middle term. So we're trying to find 2 numbers that add up to equal 0. So 2 numbers that we can use is 3 and -3. It could be in either order. 3, -3. So that's the one we're going to use for this one. We can factor this to be x plus 3 from that positive 3 times x minus 3 from the -3 over there. And then we're multiplying it. We're just going to bring down our x plus 1s. And then just like before, we're going to set all of these equal to 0. So we can find all their zeros or the solutions. So I'm going to set this one equal to 0, that one equal to 0, this one equal to 0, and this one equal to 0. And let's just break it up. And if we're using the rule that you all cooked up before, you just need the opposite. So what's opposite of positive 1? Negative 1. Negative 1, x equal to negative 1. X is equal to positive 3. X is equal to negative 3. Oops. All right, cool. And then there you are finished. So those were the types of problems you'll be encountering in your worksheets from this week.